Okay, just want to go through a idea of what it means to simplify a trig expression, and we're going to keep these fairly basic. Um, Assuming that we have a fundamental knowledge of things like the reciprocal relationships, that the sine of an angle is 1 over the cosecant of an angle, or equivalently, the cosecant of an angle is 1 over the sine. So knowing the relationships for reciprocals, sine is 1 over cosecant, vice versa. Cosine is 1 over secant, so secant is 1 over cosine, and tangent is 1 over cotangent, and cotangent is 1 over tangent. Those basic guys. And then, of course, the fact that tangent can be expressed as sine over cosine, and so its reciprocal cotangent could be expressed as cosine over sine. Those basic ideas, those 6 reciprocals, and then the cotangent and tangent being expressed in terms of sine and cosine, are so fundamental you can't afford to ever forget those. Probably next up is the Pythagorean, the fact that sine squared of an angle plus the cosine squared is always 1. And from that, you can mess around with that and say something like, okay, sine squared is 1 minus cosine squared, or cosine squared, of course, then would be 1 minus sine squared. This being the most important, but these two also get used frequently. Maybe a little less regular is something like 1 plus tangent squared equals the secant squared, or its kind of reciprocal sort of version, 1 plus the cotangent squared is equal to the cosecant squared. Those not so much as important. Come in handy sometimes, but they can never, put it this way, you can always get that information by switching things to sines and cosines and then working through that way. So with those basic ideas, I'm not going to worry about half angles nor double angles, just kind of staying with the basics here. So you get an example, something like, let's say you had the sine of theta over the tangent of theta. They said, okay, let's simplify that. So we'd say, okay, that's the sine of theta over the sine over the cosine. And knowing how fractions work, we can think of this numerator as the sine of theta over 1, and the denominator being the sine of theta over cosine of theta. And then we take our numerator and we multiply it by the reciprocal of the denominator and see what happens. The signs are going to cancel and we get cosine of theta. So something kind of fundamental like that is something that you should always be able to do fairly quickly and efficiently. Another example, and again, the squareds, just things like, let's say you had maybe something like tangent over cosecant. So the tangent of an angle over its cosecant, I'm using x's instead of thetas now, and add that to the sine over the tangent. As we just saw in that last example, we have an expression for sine over tangent. We realize that's going to go into cosine. So it may become a question, what are we going to have here? Well, let's take a look what happens with tangent and cosecant. We have sine over cosine, replacing the tangent, and cosecant is 1 over the sine. And then, of course, we saw this was just sine over 1 over sine over cos. Now, this first fraction here, the sine over cosine over the 1 over the sine, let's simplify that. We'll get sine over cosine, and that's going to get multiplied by sine over 1. And then this one, of course, we already did the, oops, I don't mean to put an equal sign there. That is being added to that second fraction, which we saw up here turned out to be cosine of theta. So we might want to write that as cosine, well, cosine of x in this case. So we now have a sine squared from this first quantity being over cosine being added to a cosine over 1. And of course we've talked lots about the importance of when you have two separate fractions, to be able to add them together you need a common denominator. So we can say, let's put a cosine of x there and a cosine of x there. And you might be able to spot the finish line. Our common denominator is now cosine, but our numerator is sine squared plus cosine squared. And we should recognize that numerator as 1. So 1 over cosine of x would be a nice simple way to write it, or recognizing that that's just secant of x. So that's the kind of stuff that should be fairly fluid now that we've studied all this trig. And maybe you can throw maybe one more example just to make sure that we're cool with this stuff. So we can look at something like the cosine of the fourth minus sine of the fourth, and just to simplify that now. This is something where, like, maybe in a multiple choice format there might be a lot of different options, and you just kind of have to shake this thing around a little bit and see what happens with it. But undoubtedly, seeing two terms raised to the fourth power with a difference between them, something like x to the fourth minus y to the fourth, your algebra alarm should go off and say, oh, that's x squared plus y squared times x squared minus y squared, using that difference of squares pattern. Now, this guy further is a difference of squares, so you could say, all right, that's x squared plus y squared, and then this breaks down to x plus y and x minus y. So maybe applying something like that for this, where instead of x's and y's we have cosines and sines. So you could say, all right, this factors to cosine squared, let's say cosine squared plus sine squared. I don't know why I put a y there. Cosine squared of theta, sine squared of theta, and then cosine squared of theta minus sine squared of theta. Now, there's the fun. This shows up in lots of textbooks as kind of like a nice teaser because it does bring back the algebra. But cosine squared of theta plus sine squared of theta is always just 1, so that's a wonderful simplification. So you might be just looking at 1 times cosine squared minus sine squared, which is a wonderful simplification, cosine squared minus sine squared. That might be as far as you want to take this thing. You could break it into cos plus sine times cos minus sine, but generally those first powers of cosine and sine, mixing them up is not generally a good thing. But you could say, okay, well, use our information, something like cosine squared of theta is 1 minus sine squared, and you could replace that cosine squared with that and get something like 1 minus sine squared minus sine squared, which then would become 1 minus 2 sine squared. That would be an equivalent expression. You could have replaced the sine squared with 1 minus cosine squared, and take this guy out, and then we'd have cosine squared minus the quantity 1 minus cosine squared. And in distributing that negative there, you're going to get a cosine squared plus a cosine squared, which would be 2 cosine squared minus 1. Take the negative into that 1, it's going to be a minus 1. And with all of those, you probably recognize, hopefully by now, cosine squared minus sine squared was one of the versions that we had of cosine of 2x. Now, again, I said earlier I'm not going to be focusing on cosine of twice of an angle, or sine of double an angle, or cosine or sine of half an angle, but just kind of being fluid with these manipulations that you can do with cosines and sines using the Pythag. Sine squared plus cosine squared equals 1 is always a good thing to have on tap.